So at this point, you've seen a few examples of how finite representations of numbers can affect numerical computation. But you might be wondering, okay, so how does this affect me? Well, to answer that, I'd like you to think about the following example, which you might find a little bit surprising. Consider the following program fragment. Let's call this program 1. I admit it's kind of a silly program, but take a moment anyway to pause and ask yourself, what value will the variable t as in Tom have after the program completes? Now let's consider a different program, program 2. Think about it too for a moment. In fact, if you told me it should produce the same output, any reasonable person would agree. And what would that person say? Well, if he or she said that t should equal a, that seems about right. Or does it? Well, let's do an experiment. Here's a Python notebook containing the two program fragments. Check out the initial values, 1 and 0.1. Because you're very observant, you might already be suspicious. In particular, you know that the machine usually stores numbers in binary, yet 0.1 in base 10 expands to an infinite binary representation. Now, does that mean that the programs will produce different results? Well, let's run them and see. Here's the output. Everything looks normal at the beginning. And what about programs 1 and 2? Well, it appears that they produce the same output. T1 from program 1 equals 1.0, and the same is true for program 2. Now I've added a little assertion at the end just to make sure. The assertion passes, so everything seems okay. So what's the big deal? Well, let's try a different input. In this case, I've picked the value of b to be an exact power of 2. Since the computer stores everything in binary, unlike the previous example, this value can be represented exactly. And that's true even though the printed output, which is in base 10, shows a messy result. So let's run the two programs again. Ooh, it looks like they've produced slightly different results. Indeed, this fact causes the assertion to fail as well. So what's going on? In one case, with inexact inputs, the two programs produced exactly the same results. Yet, with exactly represented inputs, the two programs produced different results. So with everything you know so far, you should be able to explain what just happened. So take a moment to think about that. When you come back, we'll dive into the details.